So welcome to the R session as offered by the your final mod at Flatiron School. So it would be, I would not be able to sleep at night as an R user, knowing that I have students that work in the world of data science without at least giving them sort of crash course in R. The way that this session is going to go is we'll take, it could last anywhere from 2 to 3 hours. I could talk much longer about it, and if people want to get into things, of course, I could talk about this for a long time because this is sort of like my native programming language and the space that I work a lot in. But the way that I want to divide this up very much follows the link that I sent out with this R for Python crash course. So I'll spend a little bit, maybe 10, 15 minutes at the front talking about some of the technologies associated with R and the R programming language. So it's not just R that's interesting in general, but rather sort of like what things are built around the R programming language that make it really nice. And then what we'll jump straight into is basically applications and usefulness and like sort of where does R excel in a way that Python is good, but maybe necessarily wasn't designed for. So the way that I introduce people to R is that it's a programming language like for statisticians by statisticians. And that's not completely true because it's not just statisticians that use it. But if you do work with like tabular or rectangular data, R and this thing called the Tidyverse, which I'll tell you about, is actually quite helpful for that. So I'm going to swap to share my screen. And then I'm going to pull up the old chat so I can see if people have questions as we're going. And then start a new thing. So the first couple of minutes, I want to make sure everybody has the correct stuff on their computer if they want to get this working. So if you installed Anaconda and whatnot, there's some version of RStudio that comes with the whole thing, but we always run into problems with it. So if you do want to follow along and have this on your computer, the first thing that you need to do is go to CRAN. So it's cran.r-project.org. And CRAN is basically the central repository where everything R related lives. So if you have a package or a library that someone's created that you sort of want canonical and available to everybody that uses the R programming language, you'll find it on CRAN, as well as sort of whatever the most up-to-date version of R is. So here, if you want to update, you would click this, whatever, click this package, install it. It literally takes like 2 minutes to install the whole thing, which is really nice. You can do that while I'm talking. And once that's set and installed, so I won't go and go do that next. The other thing that you are definitely going to want if you start working in R is this thing called RStudio. So RStudio is an IDE, meaning interactive development environment, that was specifically designed to work with R. RStudio is a company, and it's a company that specializes in all things data science. It mainly does R stuff, but right now it's kind of making a bid in terms of like the world of data science to be one of the center players in terms of like getting corporate support for your company as like a data company or whatever. So you might be working on a team of like 4 or 5 data scientists. You're ready to sort of scale up and have the sort of data side of your company be bigger. So you might not want to do that internally, but rather in the same way that you sort of leverage out server space for Amazon, like web services or something, you might want to have a cross-platform, cross-company sort of server platform, whatever, for integrating across different data science workflows. And RStudio, especially the RStudio IDE, is really trying to make a bid to do that. It just recently became a public benefit corporation in the United States, meaning that basically they're not completely a for-profit company anymore, but rather have to make decisions with the business in mind, or with the future of the programming language in mind, which is quite nice. And the latest thing they've been doing, if you notice here from the website, is that they're really trying to make it so it's so R and RStudio can integrate with Python through a package called Reticulate, which we can talk about at the way end if you would like. So hopefully by this point, R is downloaded on your computer. If you're following along, you've installed it. It shouldn't have taken too long. And the next thing that you want to do once R is installed, which is just the programming language, you could install RStudio Desktop, which is right here. Choose your version. You can get the free version of it unless you're a massive company. You want to get all this garbage here. But then the whole thing will download, and then you'll be able to use it on your machine. So are there anyone that is there anyone that's following along with this and going to try to follow along on the downloads, or do you just want me to sort of go for it? Okay, Robbie's following along, good. So if you have questions or get stuck while you're doing this, feel free to yell out here or there. And yeah, and great, Antoine's already jumped on the Tidyverse stuff. Okay, wonderful. So moving on to our next section. So when you work in the world of R, you'd be like insane to just work with R as a programming language. So you can do this. So if you open up your terminal, just like if you type in Python and type R, you can get the whole programming language R sitting right here and do stuff that you might normally do. Say, hey, what's 2 + 2? Save objects into R or whatever. But like you have to be a straight up masochist to actually use R at the command line. So I'm going to quit out of it with quit. And I'm going to say no to save my workspace, which is something R will ask you a lot of. And instead, you're going to use something called RStudio. So I'm going to go over to where I have this repository on my computer. And if I go into this repository that you downloaded, you'll see a couple of different files that we're going to end up working with. So we have an intro to R file, which is something .R. That's just basically R files, just like you would have .python files. We have a couple directories in here for guides that you can refer to if you want to page through when we're done with this. But what you'll also notice is there's something here called a .rproj file. So .rprojes are meant to be little files that kind of keep track of the entire little repository on your computer and sort of isolated off from the rest of your workflow. So if you are developing some sort of data tool or data analysis, you don't have to deal with like the super awful path issue of like, do I have local paths? Where do I set all these things here? But that'll sort of come with time. But if I open it up, what'll happen here, I'll open up a new version of RStudio. I'll move this over to the side. James says, I've downloaded and works well. Glad to hear. Okay, so if you've opened this up, yes, #1 question, how do I get dark mode? This is always the first question. So I am using a different version of this. If you are, we're all on Macs, I assume, for the most part. If you go up to RStudio here and then go to Preferences, and then go to Appearance, you'll be able to pick whatever version of the colors that you want. And I know this is very important as someone who also is very particular about what colors they use. As a solarized dark person myself, you could pick whatever you want. All right, so I'm going to close this up for now. All right, so when you open RStudio, in my opinion, I'm very unfiltered about my opinions when it comes to R and Python and all that kind of stuff. Like RStudio is like 100 times easier for me to work in than IPython notebooks. Mostly because the fact that you're actually working with the file that ends up getting run, as opposed to with an IPython notebook. I don't know if you've ever actually tried to open it up as a text file. You realize it's actually a JSON file that gets manipulated, which is why there are so many merge issues. But that's not the same with dealing with things with R. So when you open up RStudio, you'll see a couple of different things. If I click here, this little green button, and then I press R script, it typically tends to launch in this format right here as the default setup. The top left here is our script editor. So if we want to write some sort of R script over here to like have it be written down, we can do that there. Below here is our console. So this is where actually everything ends up running. And then we have a little Finder window on the right. And on the top right, we actually have access to our environment and what's going to be living there. So it's a lot to sort of take in if you're just used to Jupyter notebooks, but hopefully we've been coding for a while now, so hopefully this isn't going to be too much of a surprise for people. So if I write something into the console, so now I'm here near the bottom of my screen, and I write something like 2 + 2, and I press return, it gives us some sort of answer. You don't necessarily have to worry about this one right now, what that means. It's sort of the way R stores data types and what everything in R is. Just for now, know that down here, when you type something, this is where you're going to run it. So if you're playing along and following along, try to type a couple of things into the console here, see what works, see what doesn't. If you're not following along, I'll sort of just talk for a second. You can tune me out. You can do things like multiplication. You can do things like addition, which are the same as Python, but there are some things that are different. So if you want to exponentiate in something in Python, what would I type here? If I did 3 to the 2nd power, I do 3 * 2, right? What happens when I do that here? Well, I didn't know it did that. I guess you can do that too, but you can also do 3 * 2 to get 3 to the 2nd power, or use a function to do this like you would in Python. Yeah, so that's basically the console there. Where it starts getting more fun is that obviously we don't just type things into the console in order to get things to run, but rather we write things. We can write some code and then send it to the console for doing live exploratory data analysis. So what I'm going to do now is I'm going to do 2 + 2 and write this up in the text editor. And then in order to get that to run on a Mac, I can hold down the command button and then press return. And then what'll happen is RStudio will run the line in my console down here in the console. So if I'm working on some code here and I want to keep running it to kind of check what it is, like if I'm doing some sort of like unfortunate, text cleaning or something, which I was working on a couple days ago, or I'm just like building up a function, I can continually run it here with like Command Enter and then check out what the output is on the bottom. And this will become more apparent here. I just want everybody to know that the keyboard shortcut to get that to happen is Command Enter. On a Windows, I think it's like Function Enter or Option Enter. I just don't know the exact name of it. Okay, so we can run that. The next thing that I want to start talking about is what is the actual environment. So 2 + 2, obviously not that interesting from a programming standpoint, but if I were to save it into an object, there's 2 new things here. So the first is that in R, you will typically see this as the assignment operator. So it's a less than sign followed by a minus sign, which means this is the thing on this side of the assignment operator is assigned to whatever this object is. One of the reasons for this is because R is like for statisticians, for math people, and the equal sign means something very specific in the world of like, mathematics. It means this is exactly this. These are directly equivalent. Whereas the assignment operator sort of is meant to be more, this is assigning something on the side to a very specific name. So you can use equals, that's fine. But the style guide for R says you should use the assignment operator. If I then run this, so I'm going to run this line here with Command Enter, but where I want you to look is not down here, but over here where it says global environment on the right side. So if I press Command Enter, what will happen is that this will run. This will get saved into the current environment, and RStudio will actually track what is in your current environment over here. So it'll say, what's the name of the object that lives here? And then what does it necessarily know about that object? In this case, it's just the number 4 because I've assigned it like that. Are there any questions at this point on just sort of basics of manipulating RStudio? Okay, cool. So can you remove from the global environment? Yes. So you can either click this thing here, this little broom thing, which will remove all objects from the global environment, or you could use RM, which is also, or maybe it's not RM. I rarely, if ever, do it now, but yeah, there's definitely ways in order to do that. So I click that and it erases it and it's gone. RStudio has tons of other stuff that hopefully is a bit intuitive if you play around with it, and you guys have been coding for long enough now that you could probably figure out what these commands mean. A history command, connections, that's more for integrating with a cloud thing, but it also has Git version control within it. And then the other things that I then want to show you before we start looking at things that are actually useful is the other type of stuff that RStudio can create. So if I go over up here on the top left, and you can see that I can create more than just text files. So instead of just saying like new, Python 3 notebook in Jupyter Notebooks, we can make things called R scripts, R markdowns, shiny web apps, text files. R has a bunch of C++ integration to get it to go super fast. Python scripts, which we can talk about again at the end. But the main one that I want to show you is this thing called R markdown. So if I make something called my first markdown, what this does is kind of the RStudio equivalent of Jupyter Notebook. And what it allows you to do is to write directly into a file here. And then what I can do is press this button up here called knit. And what knit will do is it will take the R markdown file and then convert it into some sort of like typeset thing. So if I click knit to HTML, notice over here that like I've taken some R code, and then what it's done in the background is taken everything there and turned it into an HTML format. So you can basically, any markdown site that you can write. Yes, it is very cool. So I don't even get me started on all the crazy other stuff it can do here. Is you can start making reports, right? So Antoine says, yeah, is this the equivalent of the restart in Jupyter Notebook? Yeah, if you clear everything with the broomstick, yes, that's basically the same thing. But it won't kill any processes that you currently have if you remove the thing. You'd actually have to do that from the command line by pressing escape or Control C. So in addition to HTML documents, you can also knit it to PDF. So you have to have a LaTeX distribution set up here, but now you can take the exact same thing and have it be a LaTeX document as well. And then you can have both text in here as well as R code and the output. And of course, you have control over all of these different outputs. If you read about R Markdown, but literally we could do an entire hour or two just talking about how R Markdown works. But if you get how this works and you live in this environment a lot, it's really beneficial. So like all the reports that I write for the consultancy things I do, I write in R Markdown. My entire website is just basically a lot of R Markdown pages strung together through a package called Blogdown. And I also wrote my entire PhD thesis in Bookdown, which is a way to basically write markdown formats and then render it into a book. So all you have to do is change what the sort of metadata is here at the front, and you press knit, and then it turns into a book, or turns into a website, or turns into whatever. So the whole idea is like, if you invest heavily in the R and RStudio world, you'll get really good returns because everything is the same. You just render to different formats. So the idea is like have the central language be all things R Markdown, and then everything else, so like some developer takes care of and you never have to think of by yourself, which is really nice. Okay, this also works with the thing called Shiny apps. So I'll, can I, okay, guess not. I just want to show you what this is. So the other thing that you can make with R and RStudio are all of these things where you have like interactive data apps, so very much like interactive Plotly things or whatever. And they're really pretty, and they're great for like rapid prototyping of stuff. So you can like have a look around on the website. Some people have made maps. Some people make things that show how certain algorithms work. This is just sort of like the bare bones example here. that you can use. Yeah, it's basically Tableau for stats nerds. Yeah, it's like completely customizable. You can put it on a server, you can have it locked down, you can do all this stuff with it. And it's my next side project of something that I want to get really good at. Of course, this isn't loading. All right, there we go. So you basically, with this amount of code here on the server and the UI, you can change different things. And make your own custom applications of stuff, which is kind of fun. Cool. All right, so that's a broad tour of all things R. So I don't want you to go away thinking that, oh, R is just like another programming language. There's sort of like a whole ecosystem around it, which people really like. But now we'll actually get to the coding stuff. So before I go on, are there any like general level questions about RStudio, R Markdown? Can it do this? Can it do that? Yeah, okay, yeah, let's get to the fun stuff now. So you'll also notice here that all of these make files in my little directory here. So I'm just going to delete those there as we're going. Okay, so I'm going to be doing a bit of live coding here to prove to you that I can live code and not I'm just a runner of Python code in cells. So again, just like the world of Python, the world of R has tons and tons of libraries or packages. We tend, they're called packages. So if you want to search for them, you can look for them under the word packages. But the script that you use to, the function used to load them is called library. So just like in Python, you need to have the packages installed on your computer before you can actually use them. And you only have to do this once, just like you have to pip install something only one time and then you update from there. It's the exact same thing with R, and R takes care of all of that. So if you haven't done this already, in your console, I suggest that you type install packages and then one called Tidyverse. And this is going to tell me I already have it, hopefully. But what the Tidyverse is an entire suite of packages that is built around the idea that if your data is in a tidy format, then you should be able to do anything else from there. So there's one universal format. It's called tidy data. It's one observation per row, one variable per column, and only one type of data per column. And then from there, everything is fair game, because it's like you could do whatever you need to get it to that point, but then once it's in that format, you can use all these different packages. And they're all part of this thing called the Tidyverse, referring to tidy data. So now that I've loaded in the Tidyverse, we've talked about this, we're going to start actually manipulating some data. So Gus says, so less format conversion than Python. Not really, like it has, once it's in sort of a CSV example, that's where we want it to be. Our people are not particularly fond of JSON. That's not because it's not useful, because it's very hard to work with in R. But once something is in the tabular format, so like what Antoine was talking about, once you're set up for exploratory data analysis, everything goes quite quickly here. Cool. So if I wanted to start doing some sort of analysis here, I'm going to start typing some function to load in the libraries here. In this case, it's library. If you have RStudio on, you'll notice that as I start to type something, autocomplete, there's like tons of autocomplete in RStudio, which is really nice. And if I type lib and don't even touch anything, all the different auto options come up. But what I can then do is scroll down to one and then press tab. So I scroll down to library and then press tab, and then it'll auto-complete for me. So if you ever see me auto-completing in RStudio, I'm doing it with the tab command. What I want to do next is load Tidyverse. So again, lots of autocomplete there if you're watching your screen. And then once I do this, I'm going to press Command Enter, and that again is going to load the Tidyverse. So in R, things are a little bit different than what you might be used to with Python in terms of actually calling a function. So in Python, if we wanted to read in a CSV file, we would type something like pd.read_CSV and then pass it whatever the name of that CSV file was. We have to specifically say a lot of the time in Python, from what package or library do we want to load things, and then say, oh, pd dot whatever. We don't really do that in R. We just have the names of the functions. But if you did want that, what you can use is this format that basically says, oh, specifically, I want something from the dplyr package called, read CSV, read R, called read CSV. You won't see this written a lot, but I do want you to know that it does exist, because sometimes it comes up with a problem in the sense that a couple of different packages might claim the same name. And if that's true, when you do load a package in, if you look here on the bottom of RStudio, you'll get something that's a conflict here. So you'll say the dplyr filter function masks the stats filter function. So stats is a package or a library that comes with base R. I say base R, like this, base R, which is basically kind of like vanilla R out of the box. And people don't really, people still use it, obviously, but it's not where the main draw is to R. And if you're really interested in it, we can talk about base R, but I just don't see a advantage in that right now. So we've imported the Tidyverse, which imports all of these different libraries, not just one at a time, which I think is always quite nice to do. So we talked about this here, reader. Okay, great. So does anybody have any favorite data sets that they like to work with? Or I'll just pick the diamonds one for now. We'll stick with diamonds then. Okay, cool. So, actually, we don't really, it already comes loaded in here, so maybe that's not a good idea. So once you load the Tidyverse, you actually get a couple of different data frames or data that you can then use. So one of them that comes with the Tidyverse is one called diamonds, and something that I've used before. And if I run diamonds here, you'll notice what happens is that I can see something called a tibble here. Let me pause for a second. Gus asks, where is DevTools? So DevTools is a specific library. You might have to install it. So if you did need to install it, you could do install .packages DevTools like that, and then run that, and it'll get you this specific library called DevTools. And then if you want a package that anyone's written on the internet, then they host it on GitHub or whatever, you can pull it in with that. And there's tons and tons, there's probably even more packages on GitHub that people have written that aren't on CRAN that you can then use. Does that help, Gus? Yes, okay, great. All right, so the way that you read in data into R, just to sort of be clear about this, this is gonna be a bit weird, but I'm gonna create the, I'm gonna run some R in R. So notice I've gone over here to terminal if you wonder what I'm doing. I actually have an R session in an R session right now. Okay, I just want to show you how this works. So ignore what I'm doing right now because I didn't prepare this. Okay, so I just wanted to make a local copy of what we're going to be working with here. So notice that in my working directory, which you can actually find by either typing get_wd or just looking right here in between the console and the script editor, you'll see I'm in R for Python crash. also listed right here. We have a CSV file called diamonds.csv. If I wanted to load it in, I can basically type this, my diamonds, and just like in Python, it's read CSV, and I pass it a character string of Python of the name of the data set. All of the read underscore functions have tons and tons of other options, just like you have in Python. So you can declare the column names as you import it. You can guess the locale in terms of like what language this might be in. You can add comments, skip lines, tell it to only import the first however many rows. If you have a giant data set, you only want to work with part of it. And all of the functions within the file will do that. When you do import data, especially with the read family, it will tell you what its guessed everything is right when you import it. So I've ran it right here, save something into something called my diamonds. On the top right here, we see that it says, okay, it's a data frame because there's this little icon here. It's 53,000 observations of 10 different variables. It tried to guess what the formats are. So you have a double, meaning a number, but we'll get into that in a second, as well as character functions, as well as characters. So this my diamonds is the same as diamonds, so I'm not going to reassign that for right now. But know that when you do import something, it will try to guess what formats things are in. So just like in Python, if you want to get a better idea of what is in your data frame, there's a lot of ways to kind of look at it. If I just run the object itself, it'll print something called a tibble. A tibble is a very specific type of data frame that works well with the Tidyverse. So again, I'm showing you something that's like kind of the way that a lot of people do it. That's maybe not R as a hardcore programming language, but it's there for you if you want to talk about it. And what does it do? Well, it prints out all of your different variables with their different columns, as well as a guess of what variable type it is on top of that whole thing. You can, the kind of cool thing about it is that it works really well with RStudio. So if I, for some reason, were to change my viewer panel like this and run the whole thing, RStudio will recognize this and it'll reorder my output so that it's easier to read, which is quite cool. Of course, I have to run it again to get it in the right format. But then you can sort of see your data here. If you're not a big fan of looking at it, if you want to actually look at it like you would look at something in Excel, you can use the view command. And if I say view diamonds, what'll happen is I'll actually get a page of my entire data set hanging out over here. So if you can like scroll through it, obviously I would not suggest trying to manipulate this or sorting it from that, because there's a way to do it from the command line. But if you do want to see your data, and I like to do it just to sort of see if there's like any, things hiding at the way bottom or at random spots that I might not be aware of. But that's always fun to do. Or we can do, yeah, just diamonds as is. There's also head. Oops, which works in very much the same way, but it only gives you the first like 6 or so different columns. There are more traditional ways to access this information too. So if I do stir, which in Python is not what this means here. So stir in R means structure. I do diamonds. What I'll also get is basically what does R think is happening under the hood. So I'll pause here for a second to answer some more questions in the chat. Do I need to install in the console page or source on save page? No, you mean for installing a specific package, James? If you need to install, essentially what you want to do is basically use the console. You can see right here, it says console. This is where you would type install packages, and then in a string quotation, say whatever package you necessarily want. Yep, okay, great. So next thing to notice here because it's gonna come up very soon as we go on, is there are different data types inside of R that are specific for working with data frames. So unlike Python, just gotta go to coding challenge review. Okay, great to hear, Paul. We'll do this again when you're in mod 7. The other thing that's great about R, oh yeah, same thing, Ronnie, is that R naturally sort of like comes vectorized. So if you remember before in Python, like we have to turn something into a NumPy array before we can do some sort of operation on it. But that's not necessarily the case with R. So if I make a string in R that's the numbers 1 through 10, and I just have it set up like that, if I want to do some sort of math on the whole thing, there's no need to turn it into a NumPy array in order to do manipulations on it. Everything in R is vectorized already. It's something that if you take advantage of R's vectorization, it goes really, really fast and makes the calculations perform very, very quickly. Okay, we're almost to the fun part, which is the exploratory data things, but I want to cover all these points here. Okay, so in R, we have numeric data, which is probably unsurprising. We don't call it a float in R. It can take 2 different values. It can either take integers or doubles. So integers are just numbers, like real numbers without decimal points. And numbers or numerics will have some sort of decimal on them. We have characters, but there's also another thing in R called a factor. And a factor in R is an ordered category. And when we get to plotting, you'll see how this works. And that's how it's really, really nice for actually grouping variables and doing some sort of manipulation on them. Okay, so let's actually get to the fun bit here. Do you want to go straight to the fun or take a little bit of a break? I know we started at 3 o'clock and I've just been talking about R stuff. In the chat, can you say either go on or 5-10 minute break? Straight to fun. Any other ones? Or is King Gus taking us out here? All right, let's go straight to the fun. King Gus, done. Okay, so we've talked about the basics. They'll come up here or there. But now let's actually talk about the fun part of R, which is mostly, I think, comes from 2 main packages. One of them is called dplyr. That's how you pronounce this. dplyr, you'll see that. And there is another one called ggplot2. We're going to go over both of these and talk about why they are so fun. Both of these packages in conjunction with this thing called the pipe is like the reason that I think R is so good for data analysis. So the idea with R and data analysis is that you should write R code as if you were to say it as a thing, right? So like, why make programming languages different than like spoken languages in terms of the way that you think, right? So in like your first week of Flatiron, you're like, you know, you have like a data frame and you have to index it with these square bracket operators to select your columns, and then you pick a group by, and then you put a median or whatever, which kind of like feels like English, but then you realize you can like move things around and it's not nearly as fun. In the dplyr package, we have 5 different verbs, at least the 5 main verbs that kind of do the main things that you want to do as a data scientist. So the first one that we'll look at is one called select. And with every single pretty much dplyr verb, the first argument that it takes is always the data frame that you want to manipulate. So in this case, we're going to be working with the diamonds data frame. Our code's not going to look like this in about 45 minutes because we're going to change something specific about it, but I want everybody to understand that the first thing that a dplyr verb or dplyr function always wants is the name of the data frame. Select is the function that will allow you to get specific columns. So if I pull up diamonds here and I want to grab specific columns, what can I do? Well, I can just say I want cut, caret, table. And if I run that, what columns do I get? Cut, caret, and table. Very fun, right? But of course, that's not exactly the maybe as interesting. What select will also let you do is select columns passing the exact name for it. So maybe I want the columns caret through price. So So I can use the colon operator for this. Or maybe I have my data frame set up in a specific way. You can get these other functions you can pass to it, such as starts with. And if I say I want all columns that start with the letter C, I can grab it that way too. If I think put a negative on front of this, it returns all columns that don't start with the letter C. Just like there's a starts with, there's also an ends with as well. Antoine asks, how does dplyr know if it is an argument or a column? So basically if you go to the default things here, so if I just tab out on select, the first argument that it always takes is data, and then any single other thing that it passes to select is something that select will figure out as like a select appropriate syntax. So it sort of does the work for you as long as you're only passing select things that select understands. Does that make sense? Does that sort of answer your question? Okay, great. Okay, so maybe we want to do a couple of things here. Maybe we're doing some feature engineering and I forgot, oh shoot, I don't want to necessarily, I don't remember what columns I want. Another thing you could do in RStudio is highlight an object that you want to run, and again, press Command Enter, and then you can run the object right there. So I find myself doing this a lot when I'm kind of doing on the fly data analysis. So maybe I want to grab cut through depth, and then I want to drop, can I do this X through Z? No, it doesn't want to do that. Okay, maybe that's not the way to do that. Maybe I would do it in 2 different steps or have it to happen another way. So that's how select works. The next thing that you want to sometimes do is something called filter. So filter, just like select is for columns, filter is for rows. So again, the first thing that I want to take is something called diamonds. And then what do we want to select here? Well, we have to figure out how we can ask it to do specific row selections. So the second thing that you pass it is basically any other sorting metric that you want. So maybe I want where caret is greater than 0.2. And then it returns to me every single thing where caret is greater than 0.2. Or maybe I want where color is equal to E. So notice if I want to do it just like in Python, a specific string request, what I'll need to do is pass it a double equal sign saying, I want it to be exactly equal to this, and then pass it some sort of string argument. And then what do I get there? Every single thing where it's equal to E. Making sense? Okay, good. So sometimes you would think, okay, well, what if I want every single time color is equal to E, or color is equal to, is it A, one of them, J? E or J, right? So I could do that as well and pass the or operator. But sometimes you're gonna have like tons of these, right? And I'm not gonna write colors equal to J or colors equal to F or colors equal to whatever. There's another thing called the in operator, which is quite nice. And what I can do with this here is say, okay, I want diamonds. And then I could say color in, and then actually pass it a vector that allows me to list it out this way. So I'm saying, hey, give me rows in diamonds where the color is in this group. So you just say everything that's in this group, that's the thing that's going to be searched against for color, which is quite nice for if you have like 6 different groups that you want to write. So you can write out your groups ahead of time without having to type it over and over and over again. Cool. All right, so next thing we might want to do in the world of Tidyverse is make some sort of new variables. So in this set here, maybe we realize that we don't, that price is in like US dollars, but we want it to be in pounds, right? So in that situation, we want to make a new variable. The function to make a new variable in Tidyverse is called mutate. And is the data indexed? No, so we try to actually stay away from row numbers in R. You can add them, and I'll show you to do that in a second. James says, sorry, what does C stand for? Oh yeah, good question. So C is something that's the combine function in R. So if you ever want to make a couple of things in a row, if I say C1, 2, 3, I can get a list that's 1, 2, 3. If I want to do C, David, James, Gus, I can combine all these different elements together in a vector. Does that make sense? Okay, yeah. Sorry, I didn't clarify that. Okay, it's a combined thing there. So if I want to make a new thing, I can say, okay, well, maybe I'm making price, and then what's the thing I want to then make? Well, I want to make a new variable, maybe called GBP. And what is that? Well, that's going to be my price variable times about the conversion rate for price. Notice if I run that, that it adds immediately a column to the end of the data frame where I've taken one variable and multiplied it in order to get another variable. Remember, I'm doing this now by just running it. If I would want to actually save this to something, I could say diamonds with GBP. And now I've run the whole thing and saved it to an object. We also have something really slick in R, which I just did that with the vim command. If I wrap something in parentheses, I can save it to an object and get the output out at the same time as well, which is something that's helpful to do. Okay. There's another, in addition to mutate, there's something called transmutate, which I think is actually kind of fun and worth mentioning. And what transmutate will do is we'll create a new variable and only take transmute, sorry, not mutate. And it takes only the variables that you've just created on the fly as you're going, which is good. Okay. Next one we have is arrange, which is the thing, basically the sort of Python. So if I want to do arrange diamonds, I can do this by price. So if I arrange it by price, notice that my range 26, it arranges descending in ascending order. If I want it in descending order, I need to pass it to descending here. So I'm able to change that. Notice in RStudio, you'll also get a little underline where the commas should be, or the periods should be, or the little ticks should be if you're Swedish. And you can change the ordering of your data that way. You could also do it based on two different variables. So I could say first order by price, then order by color, and then it'll do that for me. Notice I'm ordering it by color, which is a categorical variable, but R actually thinks of it as something called a factor, which allows for ordered variables. You say, well, this color is greater than that color, or this category is greater than that category. Okay, would you use mutate for NaN treatment values? No, you wouldn't. There's actually a really slick way to deal with NA values in R, and I'll write that down so I can, and it comes with the pipe stuff. Okay, so there's two more I want to talk about, and then we're going to come back and then talk about this with the pipe as a thing, because I just need a little break from going through this. So we got this, we got group by. Okay, so the last two that are super important here is the idea of group by. So what group by will do is the same thing that it does in pandas. Group by, so we're going to do data, and then we want to, let's say, group it by cut. Okay, oop, I see. So this is actually the point in which I want to then transition over to talking about the pipe. So let's take a 5-minute break, We've talked about some of the basic verbs, and what we're going to do next time is blow your mind and string them all together in a way that makes sense from the analyst point of view. So in, let's say, 5 minutes, let's come back, because I'm on a roll right now, and then we'll do that. So I'm going to pause the recording, and then we'll come back at 4:05. Recording. All right, so can we all say we're back in the chat here? So I know most of you guys are back. Now I'm back. I see Antoine's back. I see Ravi's back. Hopefully Gus, James, and Song are still here. Yep, Gus, great. Okay, so this is like the crux moment here, in which I'm going to hopefully convince you that R is, puts things together in a very nice way. Okay, so when we have some sort of data set, essentially we have to do a lot of things on it, right? We have to do manipulations on it. Yeah, better than Python, hell yeah. In a way that's like kind of annoying when you have to do lots of like group dys and mutates and all that kind of stuff. So how do you basically get around this problem? How do you sort of string together all of the things that you have to tell your data frame to do in order to actually do it in a way that's not making sense, that makes sense? It's not like write this thing, then group by, then do that. Yeah, doing as a pipe operator. So the reason that I wrote out all of those functions like I did before, you maybe have not seen them like that, because I really want to drill home the idea that the first argument of any different dplyr function needs to be the data frame. So if I say select diamonds and then say color, clarity, whatever, that makes sense. And then what happens if you have to like do a specific analysis of the subset of your data in Python, you might write something like this. So my data frame 2, and then you assign that to an object. And then you say, okay, well now I want to get my rows. So I'll do filter my data frame 2, and I want to do where color is equal to E. And now that's a thing. And I'll say this is, okay, my data frame 3, and hopefully I imagine all of you have written code that kind of looks like this, right? You're like, I hate this and I hate my life. Maybe not. That was pretty much my life a lot of the time until the pipe comes along. So what does the pipe do? Well, actually, let's keep that up here. If I wanted to do the same thing, since this is sort of all the big same chain of data, we have something called the pipe operator, and it looks like this. It's % greater than %. And the way to, it's called a pipe, but the way to think about it and read it is basically and then. So if you think about this as and then, notice we use the same comment sign in R and Python, then it'll hopefully make a bit more sense here. So what it does is it takes the first argument from something on the right side of the pipe and moves it to the left, sort of the left side of the pipe here. And it doesn't make any sense if I say it out loud. If I just type it out, it'll probably make a lot more sense. So we're beginning, and if you were to talk about in English, you would probably say, hey, start with the diamonds data set. And then what would you want to do with it? Well, then I want to select basically the columns, color and clarity, right? But because we know that the first argument is basically the data that we want to work with, what the pipe operator does is it takes this thing right here and sends it secretly as the first real argument of the next function. So what that allows me to then do is just type color clarity. So this here is the exact same as that there. This is really important because then what you can then do is you could just continue on to add in different pipes. So if I want to grab my next thing here, instead of writing it to a new object, I can say, okay, filter now where color is equal to E. And I run this whole thing again with Command Enter. So then what I've now done is I started to build a data pipeline. It's not exactly what it's meant when we say pipeline in the world of Python, but I can start to sort of chop up my data frame in a way that hopefully looks more human readable. So I say start with diamonds, and then grab color and clarity, and then filter rows where the color is equal to E. When we want to start doing more operations on this, we can then start adding basically verbs that start to hopefully make a bit more sense. So I'm not going to use this example here because I want a couple more different ones. So let's say I want to do what I have again. I have color, clarity. Maybe I'm going to reorganize the column things here. Caret, depth, and price. And then what I want to do is let's say, okay, well, maybe I'm just only interested where the price is greater than $1,000. Check that it works fine, because for some reason no one cares about less than $1,000 diamonds. But then if I wanted to start doing things like group by, is I could basically start threading that into my pipe. So let's say, okay, I want to perform some sort of operation on everything. So instead of saying, I want to find like the average price of all diamonds, which you might think, oh, I'm going to do something like mutate average price, and I say mean price. What that does is it gives me the mean price over and over and over and over and over again for all diamonds, right? That's not necessarily what we want or the format we want it in. We could do that, but instead of what we want to do is, let's say we have a more meaningful question that I want the average price of every single color of diamond. Well, in order to do that, I can use the group by function. And if I pass it the word color, watch what happens right here when I run this. So I'm going to run color. And then right here, it's not going to say Tibble color ord anymore. It's going to say, yes, look, so Tibble, and then it'll say groups. And what this does is it tells you, it's basically telling R that now I have grouped by my data set into the 7 different distinct groups that are part of the color thing. So if this thing exists here, groups color 7, then any operation that I now do will be done that many times over on the group level. So if I then want to perform some sort of operation, I could try to do the mean thing again, but because we're now doing it per group, we need to use the command summarize. And basically it looks exactly like mutate in a lot of ways. I shouldn't call it that, mean price of color. So if I run this here, basically what will then happen, I say, okay, group by color. And then what I want you to do is after I've grouped by something, I want you to summarize all of my data. Well, what am I going to do? Well, I want a new variable called mean price of color. What is that? Well, it's the average of price, knowing that things are grouped by, which is kind of fun, right? So then what we can then do, if we're just sort of doing this on the fly, say, okay, well, I figured out the mean group of price by color. Maybe that's helpful, maybe that's not. But if I wanted to say, okay, well, what about color and clarity? Well, no problem. You just add it right in there, add another categorical variable, and it does every single calculation for you at the group by phase right there, which is quite nice. So this is kind of like the fun part, right? So with being able to select columns and rows and grouping things and summarizing different variables, that's pretty much like 90% what we do as data scientists, right? When we're doing exploratory data analysis. So if you need to chop up your data in a way that makes sense, that you want to think about very quickly, getting good at these different commands will help you do that very fast. Yes, it's 100 times simpler than pandas, especially when you're teaching beginners. So I don't know why we don't take like the same approach that software engineering does, that teaches Ruby first, then moves on to like Rails and JavaScript stuff, and we start with R, because this happens super, super fast. Okay, So the fun then continues here. So it doesn't just end at this, right? So we can chop up a data set as we're going. But with knowing that the pipe operator can still pipe stuff to other things, there's no reason that we can't continue to pipe what we're looking at into something like a data visualization or something like some sort of machine learning model that we want to run, knowing that we're going to mess around with stuff ahead of time. So before I get into the world of visualization and ggplot, and it looks like some people are typing some things out, I want to discuss the NA problem. So one thing that's different about R that I can't remember exactly how it works with pandas is that we have like NAs here. So there's no NAs in this data set because it already comes pre-cleaned. But if I wanted to get rid of them, what I could do is basically do oh no, it's not a filter. So if I can basically use the filter command to use an is.na and say like basically find all rows where NA equals true. Maybe I'll do that. I'll write that down here at the end and I'll make an example when we're playing around with this to show you. There's also a function called NA omit, which is kind of fun, but I'll again make an example when everybody's not watching me. Okay, cool. So let's get on to the next fun part, which is actually making graphs in ggplot. So, does everybody have any questions? Or does it just seem too simple, too easy? I'll take the awkward silence as a please continue. My brain is melted because I'm working on mod 7 stuff. James is okay. Thank you, James. Great. Okay. So how does ggplot work? Well, ggplot works very much like matplotlib works in some ways, in the sense that you have to layer things together. So the GG in ggplot comes from grammar of graphics. And the whole idea behind it is that if you understand the grammar of basically how data visualizations should work and link to data, so you can't have a data visualization without data, then you can create any custom visualization you want because you know what that mapping from data to visualization is. So let's talk a couple of basic things before we get going. And then I'll just go through a couple of examples here and see what kind of cool stuff you can do. So just like before, if we want to run something in ggplot, the first argument that it'll always take is the data. So we'll swap this around a second. Hold on, I'm getting a phone call that I was expecting. Hold on 1 second. Hello? Yes. Okay, sorry about that. I was expecting that call. All right, so back to this. So again, with all things Tidyverse, the first thing that it's going to want is the data set, diamonds. And then the next thing that we want to tell it is basically what aesthetics are we interested in? So what are the things that you're going to see on the plot that we eventually want to plot here. So if I just run ggplot, what it will do by itself is just sort of say, hey, I know that you want to make some sort of graphic, but I don't know what kind of graphic you want to do. So what I want to do, I need to pass it an argument called AES, A-E-S for aesthetic. So let's say we want to make a scatter plot, and we want to plot the caret of the cut against the price of the cut, because we believe that the caret, how much it weighs, is going to have some sort of impact on the price. So I say on my x-axis, I'm going to want caret. On my y-axis, I'm going to want price. If I run this, what'll happen? Well, it gives me a plot still, right? And on my x-axis, it's figured out that I'm going to be using the caret variable, but I haven't said what data I want to use exactly yet. And on the y-axis, I have price as a thing, right? So in addition to saying what are the aesthetic mappings that you want, you also need to tell it basically what type of geom do you want. And that's a specific thing towards ggplot2, a geom, which tells you basically how are you going to organize the data, or what kind of data do you want to have on here. In our case here, we want to make a scatter plot. So it's not called scatter plot in geom, it's called point. So if I say geom point and I run this, I'll be able to say, hey, with this mapping, use this way of looking at the data, which is a scatter plot here. You'll also notice here that I've added a plus here as opposed to a pipe. So ggplot was made a lot earlier, before the pipe was sort of like invented, discovered within the world of R. And if this eventually might switch to a pipe, I'm not sure if that's true, but as soon as you write that first line ggplot, everything else is going to be a plus afterwards. So I run this here, and then of course I pick the diamonds data set, which is absolutely massive, and it plots all of the different points. So all 53,000 points are now plotted on this. Does that make sense? So once we have this here, there's no reason that we can't, again, like start messing with things in the way that we did with the Tidyverse before. So just like we ripped out diamonds in front of this and put it ahead to be a pipe, we can do the same thing here and say, okay, let's do diamonds. Put ggplot here. R is actually tab agnostic. So it doesn't necessarily matter if you have tabs or spaces, even though there are conventions. And I delete this here. If I run this here, what am I going to get? As it loads, maybe you're thinking, maybe you're brain dead. We get the exact same plot, right? So because we do this, well, then what we can do is kind of like basically incorporate our filtrations and our selects within the same pipeline of a ggplot. So I could say, okay, well, maybe I'm just interested in where the price is less than 5,000. Well, how do I put that in? Well, I'll just say filter where price is less than 5,000, and then pipe that into my ggplot. And then what do I get? A zoomed in plot of where the plot is 5,000. If I want to mess with other things, that's totally fine as well. But then you can kind of like sort of use these two in conjunction with your data exploration, right? So you're trying to like see what's there. You're trying to do it quickly. And what's the last thing you want to do when you're trying to get a lot of information quickly about is like struggle with typing out tons and tons and tons of code that doesn't necessarily make sense. So we can do that here. I'm going to just keep it at this for now, so I don't have to wait for it to load every single time. But then what I can also do is start looking at different aesthetics. So even though that we have points here, there are other things that we might be interested in, right? So we might be interested in some sort of categorical variable that we'd want to see if there's a trend in there. So if you have categorical variables, you can map them to different features of your data. So right now we have one called, let's say, cut here. And if we want to group it by cut, we're not going to group by cut, even though it might seem like the next thing. But if I want to say color equals cut, I'm passing cut to the color aesthetic. And then if I run this again, what ggplot will then do is basically plot all of the data that I have according to color. Say, okay, maybe I don't want it necessarily just for that right there. I'll run the whole thing again. I have no idea why my default colors are Viridis right now, but I guess that's the way that it is. Making sense here, right? But then if we want to start playing around with our plot and say, okay, this is pretty good. I want to send it to my manager, but I don't want to send it with these default settings in it. Basically, what we have to then do is just keep on adding on with the plus sign here, different layers on top of our graphic that allow us to do other things. So if I say labs, I'll pass in the labs function here. And I'm going to say I want to put a title on it, and that's going to be my new diamond plot. Y is going to be price in USD, and then X is going to equal carat. The whole thing renders again, and what do we see? Some sort of default mapping towards what these things are. R also comes with an entire suite of pre-packaged themes. So if I personally like one called theme minimal, and it basically takes some sort of pre-packaged setting, and if you just add it to it, it rips out the plot from before and sort of gives it some default settings that are actually not too bad. This, are there any questions on this thus far? Nope, good. So hopefully you're seeing the value in this and say, okay, I can make plots really fast on the fly, and they look really, really nice. It doesn't end there. You can even do more weird shit. So another thing you could do is if you have other categories and you say, okay, well, I have my cut mapped onto color, but I also am really interested in the idea of, oh, sorry, no, yeah, cut mapped into color, but I have a variable called color, which is confusing. And let's say I think that there are going to be different patterns based on the color. One thing you can also then do is there's something called a facet wrap. And if I pass it the word color, which is a variable in my data set, what it will then do is create a separate plot for every single different thing in my data. So I can do this here. RStudio will resize this quite nicely for me. And then I could look and say, it just takes a second to re-render every time you move it. But it has to do a lot because there's a lot of data here. So hopefully this will not look like it's stretched. Yep, there we go. And now I've facet wrapped it and I can look at every single different plot. So then the fun part comes is like, okay, I'm doing data analysis and maybe I see something weird in like the E and the F group, and I say, okay, they're actually not part of the thing that I want to look at. Say, screw them. I'm going to sort of take that out of the plot for now. What do I need to do just to get rid of them? Where I'll just say, okay, well, filter out where color is not equal to, let's see, E, and then pipe that into my thing. And then what happens? I'm going to lose the E plot. And it's as simple as that, which is quite good. Final project moving to R. That's what I like to hear. I don't think you're allowed to, but more than welcome after this to talk with me about other stuff. What does the tilde in front of color mean? So the tilde in front of color is basically just the way that the facet wrap argument needs to take. It basically says, this is my categorical variable that I want you to split by. So it's basically split by this variable here, which is kind of fun. There's another side to it, which is facet grid. If we have a different type of variable, but I'm always like torn on like how to best present information in this workshop. I kind of just like want to get people like hooked on R, like be the guy that gives you your first your dose of R, and then you can always come back and I'll talk with this, talk about this for ages. So in this setting here, well, let me take some questions first if people have them, or I'll talk about bar plots next, which are a little bit different in the world of R. I'll take that as no questions. Okay, so that was with scatter plots. So scatter plots actually map the actual data onto the thing. Antoine says, what about maps now? You mean like geolocation? Yeah, there's a whole library of stuff that does it. I have never really do it because it's just not my sort of world of research. But if you're interested, I can send you to all the resources. I'll write that down now. Geolocation. Great. Okay, so the other thing that's also worth mentioning is the idea of basically bar plots. So bar plots work a little bit differently. There's a couple more things you need to be aware of that aren't as straightforward as making scatter plots within R. In the sense that, like, with a bar plot, right, most of the time you're not looking at the data itself, but rather some sort of collapsing of the data, right? So, or maybe a count of the data. So let's say we want to make a plot here, diamonds. And now I say, okay, take the data set diamonds here, and I'm going to make a GG plot. The x-axis is going to be cut. And then I want to do bar. Is this correct? Oh no. Oh, duh. Forgot AES. I get so wrapped up thinking about how little code you actually need that I forget to type the essential code. Oh boy, I'm just writing crap code here. Okay, so what if you pass data to geom_bar? You basically have to look in the documentation to see what is the default format that everything expects. And what geom_bar expects normally is the raw data. So geom_bar will actually do the calculation and the collapsing for you of all of your different data. So it'll count everything up and then plot what these max numbers are. If you actually just have a data set of those raw numbers, there is a way to get that out. Where's the scatter plot gone? So I can either run it again right here, or I can press this little arrow here, and I can pull up my old plots that I've had from before. So they all live in the RStudio viewer here, which is really nice. But yeah, so hopefully bar comes back up, or we'll just run this to get it to come. What's that? Go away. Okay, there we go. So just like we can pass different aesthetics to the color and line in a bar plot, we can also do that here. So we can say, okay, cut equals color, and let's say, so you might think that it's going to be color equals color, as in our variable color, which looks a bit funny. But in geom_bar, you actually need to use something called fill. And what fill will do is it will fill in the bar plot of whatever you're wanting to plot there, which is quite fun. One thing I should also show you as well about this fast wrapping aesthetics called filler is that in a scatter plot here, you can also pass it geoms that make other calculations. So you can actually fit linear, like whatever model you want inside of this. And there's a whole geom called geom_smooth. And so if I wanted to put a linear model on every single different data set that I have here, I just add in one little line here. And what does it do? Because it knows that I've basically had some sort of grouping variable and I'm asking it to do a linear model of every single one, it'll plot a linear model of every single variable there. And you can pass it whatever formula you want in order to have that happen. So it's like, again, I could do like ggplot for a very long time and sort of talk about all the weird things that you can do with it. But this sort of gives you an idea of like, okay, how does the syntax work? And like if you would just start reading the documentation and just to run basic examples, to feel like you have at least seen this happen once or twice before. So basically, to recap what ggplot is doing, you're taking some sort of data set. We're doing filtration ahead of time. You don't have to necessarily do this. And then we're taking certain aspects of the data and we're passing it to something called AES, which stands for aesthetic. Once you have those and the aesthetics are mapped to something, then you put on the layers, which basically says what type of data do you want for this. If you're interested in this, the R for Data Science book is absolutely fantastic at explaining all of these concepts. And if like we actually taught R here, then I would base all of my lessons on those chapters. But that's sort of the next point, the next set in which you would go for that. Are there any other plots or like sort of basic things that people might be interested in for this? If not, I'll show you how to run linear models in R, which is basically, again, follows sort of like a universal format. And once you kind of get that, then everything else follows from there. You make a correlation heat map, or yeah, yeah. So basically, I can't remember off the top of my head. I'll just look it up. All right, so all right, so there's a couple of different ones that you can do. So essentially what you have to do is pass it to something called geom_tile once you have created the correlation matrix itself. So I'll try to do this. I'm going to look over here on the screen to sort of see what I'm doing. But to sort of show to you, it's not terribly difficult to do this. So I might pass this to something called core. Oops. It says that X must be numeric, meaning it does not like having categorical variables in there. So what am I going to do? I'm going to say, okay, I'm just going to grab the number variables. So that's caret, depth, table, let's say price. Eventually, the next release of this, they're actually going to make it so you can say just grab all the numeric ones, grab all the category ones, which is kind of fun. And then I pass it to a function called core. And it says, okay, I have this here, check. And then what can I do from there? Well, I need to take our correlation matrix and then say, what is this here? Oh, I have to do something fun. So I have to actually turn it into a long format, which I don't really want to do right now. Core round. Let's see, this is easy to do. What? Can't select within an unnamed vector. Screw you. Okay, I'll show you later. I can save the documentation to it. It's a little more involved to have that, unless I'm looking at the wrong thing. There's a whole library called ggcoreplot that actually does it really well. Can I just get it here? Let's see, library. And I take my thing before, Tidyverse. Yeah, also things tends to either really correlate or not correlate with one another. But yeah, there's a whole library for that. And there's a way to do it within ggplot as well, but it wants it in a very specific format here. So yeah, so it can do it. It's just a matter of looking up the sort of the way that you prefer to do it from there. Okay, cool. Let's continue our speed tour of all things RStudio here, and end with like, okay, how do you actually fit models in R and do stuff like that? So in R, things tend to take a specific format. So because it's for statisticians by statisticians, the big idea is that you always want to have things basically follow this format where you think thing I am predicting followed by things that predict it. So your dependent variable is always going to be on the left side of the tilde. The tilde is going to basically means it's predicted by, comes from the world of stats, where it's saying this is stochastically defined by this relationship here. So it's not deterministic, which is what an equal sign would mean, which is another reason we don't use the equal sign in R. And everything that we do when it comes to this kind of like grows out of this thing called the LM function, as in linear model. So the way that it works is that I want to make some sort of model. Let's say I want to predict price by caret. And what I want to then tell it is basically where does it sort of follow this format. So I'm saying predict price by caret using the diamonds data set. And this is gonna, let's say, call what we need to do. If we run this, it'll run it and give us an intercept and a coefficient. But what we really want to do is save it to a object like this. Notice that it moves up into my global environment here. And what model is, and something that we haven't seen yet, is something that's called a list. And the list is very much like sort of like a nested dictionary in Python, if you will, in the sense that it could have layers upon layers. So if I go to model one and I press $, I can actually get out all of the different things that live in this object, just like you would be able to get out all the different things that live in one of your stats OLS models. So I could do, okay, give me the coefficients of this model. I could say, give me the residuals, the degrees of freedoms of my residuals. This is very much like the idea of attributes within objects in Python. Or it even actually saves the model data in here as well too. But that's not really what we're interested in. We're interested in a summary of model one. And if I type summary to model one, the output will look very much like what you're expected with a stats OLS model. So what will it tell you? Well, it tells you what you put in for your specific call. So if you're doing lots of models in a row, it'll tell you the distribution of your residuals, but I really wouldn't want to look at this yet. There's a better way to do it. And then it actually follows basically the exact same format as stats models, with the exception of the confidence intervals are not calculated for your point estimates. So you see your estimates with both your intercept as well as your coefficient here. So this is just telling you for every 1 degree unit change in caret, we can expect price to go up by $7,756. Tells you what our standard error is on these, as well as the p-values and if they're significant using the standard star methods that the APA, the American Psychological Association, and American Statistical Association uses. It'll tell you your R-squared, your adjusted R-squared, as well as the p-value of the entire model. So whether or not there's an omnibus significance test, because you can use this exact same format to do ANOVAs and other stuff as well, because everything for R people is a linear model, no matter what. Because linear model is such like a fundamental thing in R, you can actually pass, there's some of the base functions in R, like plot, can actually figure out that it is a linear model, which I won't get into. It's basically R's version of object-oriented programming called S3 leads to this. But if I actually pass the word, pass our model to the plot function, so this is not ggplot, and I press return in the console, what it will do, it's taking forever, is it'll create all of my diagnostic plots for my regression model one after another. So first it plots the residuals versus the fitted, and then it will plot the Q plot, yep, which I could sort of see, yep, doing well in the middle, awful on the sides. As expected, we have super extreme data and lots of outliers. It'll plot the square root of our standardized residuals against our fitted prices, as well as one more, which I forget what it is. Oh, yeah, residuals versus leverage. So if you're trying to sort of say, are there outliers in my model that are affecting it there, we can do that. If we want to add more variables to this, so let's say, let's not necessarily do a linear, a univariate model, but rather predicted by caret and something like depth, we just say plus depth. And now it's saved as model 2, and I can do the exact same thing. Summary model 2, and I get the entire model again. If I want to compare between the models, I can use the ANOVA function for that. Oops. Is it an AOV? Oh no, it's ANOVA. And then what I can do is compare the models and say, is there a significantly better fit between model 1 and model 2? And it tells you as you're going. So it's really a lot of like, sort of like parsimonious code for running things that statisticians love to run, which is stuff like linear models. So that's a lot that I threw at you in the past 2 hours or so. Maybe we could spend the next 10 minutes trying to like play around with some of this stuff, and then I can answer some questions that you have. So let's maybe, right now it is, actually it's 10:02. Hopefully I've covered what Ravi wanted with the exploratory data analysis. So do you feel like you kind of see now where the advantages are of using R for this?
Yes,
Gus has to go.
You can do a lot more in a much shorter time.
Yeah, it's a little more, sorry, I wasn't paying attention to the chat here. Yeah, so the best places to go for R help are, yeah, sorry, Gus, if you have to go, maybe he's already gone. Best place to go for R help, yeah, Stack Overflow has tons, but what I would suggest if you're serious about putting this on your CV and just want this as a tool in your data science toolkit is go to this website called R for Data Science, and it's basically a book that was written in R, and you can like go through the entire book for free. I have a physical copy of the book that I normally have at my desk at Flatiron, but you can get it for free online, because the whole idea is that if more people learn R and get better at R, then the value of R becomes more important, because it's sort of like the one of the big tools in data science. So it's lots of stuff. I would go there for help first, because like just read about the basic concept and then try to apply it, because the book is literally that good as a pedagogical thing. Stack Overflow, also fantastic for that. And then if you're on Twitter, the hashtag #RStats. So if you want to find it on Twitter, you have to find it under #RStats, not just hashtag R. There's a big community of people that talk about R and like all the new stuff. And there's like tons of other, I mean, it's just like ridiculous how much stuff there is. And I'm sure that's there for Python too, obviously. And there's some things that Python, I still use Python for, like some of like scraping tweets off Twitter or something. Actually, no, I actually use R for that. There's one specific, like getting very old tweets, Python is much better at. for that. But those are the best places to go. Or you come to me. I know we're only here for the next 2 weeks, but I'd be more than happy to help. And I just finished my RStudio certification training. So this is not an example of a lesson I would have planned when I'm teaching R. This is more of like, here's a ton of shit that R can do for people that are super interested and strong coders already. But yeah, hopefully it gives you an idea of it. Any other questions I can answer?
Yeah, following on that, if you do your exploration in RStudio with R, can you like move that to Python somehow?
Yeah. So there's some like, so I haven't, this could be totally disaster if I try to show you what happens here. But so RStudio, the company, has made a very big effort in the past couple of months in investing in Python as like a thing, right? So what would be like super slick, right? To be able to run R and Python in the exact same world, especially if you're on a team that uses both. So we whip it up in R, we deploy in Python, we whip it up in R, whatever. So basically what you should be able to do, so if I open up this Python example, and if you're wondering why I'm so fast at deleting stuff on the text editor, I'm using a Vim keyboard mappings in R here. So essentially, I think what you can do, if I remember this from last time, Python, I can make an R markdown file, and I can say, okay, here I am going to show you some Python. And if I insert R first and I call a library called reticulate, what it allowed me to do is actually, I think, run both R and Python in the same thing. So if I say, I can't remember how this works. 2 is going to be 2 plus 2, and that sends it to my global environment. I inserted some R code here by saying insert, put in some R. But I think I can also just say insert Python and then run a specific Python library from here. So if I wanted to do my data, and I actually did dot read CSV. What was it? Diamonds. CSV in my working directory. If I run all of these, then I run this cell here. Did that actually work? So if I do my data, oh wow, crazy. Yeah, so you can actually run pandas and things. I can't do this, can I? Oh no, it still recognizes this. So this is Python code that now lives in here. So if I want to do something like my data, the autocomplete's not as nice. Oh, look at that. Yeah, so I could actually run Python code in RStudio. So I haven't played around with this a ton, but the whole idea here is you could run both R and Python. So you might be able to like do some sort of analysis here, like in R, and then just save it as a CSV object and then run all of your Python code from there. And like in the future, I'm sure by like middle of summer, this will all exist as one big thing, and there'll be a lot of educational stuff around it. But you could imagine that if you're a company in your RStudio and you want to be like the center thing and the most valuable company in the world, you would have an IDE that runs both R and Python. And then there's none of this like, oh, I would do it in R or I would do it in Python. You're like, well, just do it in both and just clean up whatever you want. So it's helpful to do that.
Is it common for people to do the EDA in R and then completely switch out, like save down, say they do all their cleaning in EDA, then save all of the graphs and save the clean data set and then jump over to Jupyter and work in Python?
Yeah, there's nothing wrong with that. I mean, you have to like, yeah, there's no, you'll definitely meet people with very strong opinions on things like that. So people say, oh, just do it all in Python or do it all in R or whatever. But like if it fits your workflow, I would do it. Like especially if there's something that you're much more comfortable working with, like optimizing machine learning models in scikit-learn, but you just like don't have that much cleaning to do. I don't think, I think you would get pushback from some people at first because like these are new technologies and people don't really want to learn how to like do both so that you can support both of them. But I don't know. I would do it. I mean, but the thing is, like, I prefer doing everything in R. But yeah, there's nothing against that. I don't see why that would be.
And also, how far does R's capability go in terms of machine learning? Has it got everything?
Oh,
everything Python has.
So you have to remember. So R is also like the language of academics, which is why I learned it. Because I'm pretty much like, when I'm not at Flatiron, I'm pretty much identify as a scholarly, independent scholar academic. So basically, whenever someone comes up with a new algorithm or a new model or a new something, it's actually, I think, a little easier to make a library around it within R than it is in Python. So like the most cutting edge stuff will probably always be released in R before it's in Python as like a dev tools thing that you might find on someone's GitHub account. So it's all definitely there. So I couldn't think of a single algorithm that doesn't exist in an R that you would find in Python that you wouldn't find in R. And there's also a bunch of like other weird things too. Like some people don't like the fact that like I think it's like L1 regularization is like automatically added to logistic regression models in scikit-learn, where that's not the same thing in R. So you just have to kind of know what the defaults are for everything and like why you're using what you're using. But like R is actually, I think, the more zany of the two when it comes to algorithms and machine learning. I mean, in terms of actually productionizing, it's a different question, right? So like, because Python is like a general purpose programming language, you can like duct tape everything together quite easily. RStudio is trying to change that and try to like sort of speed things up. So like if you do want to have like R as production code, that's fine, but that's something you'll probably hear when you know, if you ever are allowed to go to a tech meetup again, is that people are like, oh yeah, but you wouldn't productionize R code. Like actually lots of companies productionize R code, but Python is very good because it's just like, it grows, the growing pains that R has been able to avoid some of the growing pains of like, how do you make Python a language for data science? Because like R is already like started out as being a language for statistics. So like making it a language, you know, for data science, it's actually been quite easy. Whereas with Python, I think like it's there, but it sort of has this sort of engineering bent to it that doesn't, it's, you know, I don't know if that explains it.
Yeah, no, that was good. Thanks.
Could you give us a reason why you wouldn't use R?
Oh, the rest of your team? Why I personally wouldn't, or just in general?
Yeah, like in general, you mentioned the workflow and the deployments.
Yeah. Yeah, so most people in industry will use Python for the most part. Like, so when you get to a big company, especially a big company, they will want their models probably in R, and they'll try to like basically push things like and have things on in terms of their workflow in R. So it's like in terms of sheer numbers, R is still, I think, the minority in terms of production stuff, especially at super large companies. I would definitely use R or Python if you are collaborating a lot more with people who are like actual software engineers, and like it'll be easier for you to tether things together unless you really start understanding like all of RStudio's products for that kind of stuff. And then also just general purpose programming. R is like, so we like try to avoid loops in the world of R, and we use things like apply functions to do stuff. So like in terms of like if you want to parse a binary tree or like work with like APIs where like the API is provided in JSON, like JSON is a nightmare to work with in R, and then I would much rather do it in Python because of the dictionary JSON parallel. So yeah, I'll be getting that call in a second, just so you know, in case I have to jump off the call here. But if you have other like questions about this and you want to talk more R, or like do like a mini project or something, or like try to redo part of your analysis for your final project in R, I'd be more than happy to sort of just talk with you a bit. I wouldn't suggest swapping to that now with only like a week left, with everything. But post your time here, please join the pirate ship channel. And then every time I do this workshop, you can always pop back in or send me messages, or I promise I'll be more helpful with R messages than I am with, or R questions than I am with Python questions. Cool. I'll send something out about that NA thing, because there's something very specific about NA, in that like if there's an NA in your data frame, it'll make everything NA, which is good to know if you're a statistician, because you have missing data. That's like a really big problem from a statistical research point of view. So NAs are kind of like infectious. So maybe I can show you on this here, if you can see on my screen still. So if I go my vector, and I make a vector that's like 1, 2, 3, 4, 5, whatever, NA 3. And if I try to get the mean of my vector, it'll say NA, because it basically says, I don't know. And if there's some value in there you don't know, it'll be aware of that. And you can basically say NA remove, and it'll drop the NAs, so that you can get NA out of there. But if you start working with R a lot, I would suggest actually reading about this in the R for Data Science, as opposed to this being a giant infomercial for the advantages and disadvantages of R. Oops, no, I don't want to do it like that. Oh, my vector. All right, cool. I'm just gonna dick around with this now. All right, well, if there are no other questions, I'll let you get back to your regular projects. Thanks for tuning in for a 2-hour thing on R and all things that it does. I hope I've sold you on the pluses of it, and haven't showed you too many of the weird minuses of it that you'll, if you program in Python, you're like, what the hell? Why does it do this? Right? They definitely exist. But yeah, I definitely learned both. You'll get paid a lot more, and you'll be able to hang out with more people.
Thanks
Cool.
for taking the time to do that.
Thank you. Thanks for taking the time to listen.
Cheers. See ya.
Yeah.